Have you ever stood on a beach or maybe on a cliff edge and just wondered about the incredible power that shaped everything around you? Coastlines, they feel so permanent, right? But they're actually one of the most dynamic, constantly changing places on our entire planet. In this explainer, we're going to dig into the amazing forces that build, destroy, and are always reshaping our coasts.
Okay, so let's jump right in with the big question. Why is the coastline never, ever the same twice? And the answer is so much more than just the tides coming in and out. It's a whole story of hidden forces, sudden collapses, and the absolutely relentless energy of the ocean, all working together in this constant dance of creation and destruction.
The story of a changing coastline, it doesn't start with a huge crash. It actually begins with a whisper. Before a cliff can even think about crumbling, or a beach can get washed away, the rock itself has to be weakened from the inside out. And this quiet, almost invisible first step, it's called weathering.
So here's the absolute key thing to get about weathering. It is the breakdown of rock in its original place. Nothing's getting carried away just yet. This is all about making the rock weak, making it vulnerable, kind of setting the stage for all the more dramatic stuff that's about to happen. So how does this work? Well, one of the most powerful ways is freeze-thaw weathering. Just think about what happens if you put a can of soda in the freezer and forget about it. It explodes, right? That's because water expands by about 9% when it freezes. Well, the exact same thing happens inside tiny cracks in a cliff. Water gets in, it freezes, it expands, and it acts like a tiny but powerful wedge, forcing that crack a little bit wider. Night after night, winter after winter, that cycle just repeats and repeats, slowly prying the rock apart.
Now that freeze-thaw cycle we just talked about, that's what we call mechanical weathering. But it's not the only player in the game. You've also got chemical weathering. This is when something like slightly acidic rainwater literally dissolves rocks like chalk or limestone. And then there's biological weathering, which is pretty much exactly what it sounds like. You can have plant roots forcing their way into cracks, or even burrowing animals like rabbits loosening up the soil and rock on a cliff face.
Okay, so picture this. You've got this rock that's been cracked by ice, maybe dissolved a bit by rain, and even pushed around by plants. It's unstable, it's heavy. And that is the perfect moment for the second major force in our story to step in: gravity. This is what leads to something we call mass movement. And mass movement isn't just one thing. Let's look at two main types. First, you have a rockfall. This is where pieces of rock break off a really steep cliff and just fall straight down, creating this pile of sharp, angular debris at the bottom. But in a rock slide, a whole chunk of rock moves down a slope, but it stays in contact with the surface the whole way. So the key difference to remember is free fall versus sliding.
All right, now for a really specific type of movement called slumping. To get how this works, you need a very particular geological setup. Just imagine a layer of rock that water can easily soak through, like sand, sitting right on top of a layer of rock that water can't get through, like clay, which pretty much acts like a waterproof sheet. So what happens next? Well, rain pours down and it soaks that top sandy layer, but the water hits the clay underneath and gets trapped. It has nowhere to go. That top layer gets heavier and heavier and heavier, just like a waterlogged sponge. And eventually, it's so heavy and unstable that gravity just pulls the whole thing down. But here's the cool part. It moves along a curved surface, which causes the whole mass to rotate or slump as it goes. It's kind of like a landslide, but with a twist.
So we've weakened the rock with weathering, and we've let gravity pull it down. But the real star of the show, the most powerful sculptor of our coastlines, is, of course, the sea itself. And all that incredible energy from the sea is delivered by waves, which get their power from wind blowing across the surface of the water.
And that brings us to a super important idea that explains why some waves are just so much bigger than others. It's a concept called fetch. Fetch is simply the distance the wind gets to blow across open water without being interrupted. So a short fetch, like the wind blowing across a lake, makes tiny little waves. But a really long fetch, like the wind blowing all the way across the Atlantic Ocean, that's what creates those massive, powerful waves.
And all that wave energy basically creates two main types of waves. You have constructive waves. They're the builders. They have lower energy, and their push up the beach, which is called the swash, is stronger than the pull back down, the backwash. So they drop off sand and build up these nice, wide beaches. And then you have destructive waves. They're the demolition crew. They're high-energy monsters, where the backwash is way stronger, so they drag material away from the shore and carve away at the coast.
So how exactly do these destructive waves do all that damage? Well, they don't have just one trick. They've got a whole toolkit with 4 main methods they use to erode and sculpt the land.
First up is hydraulic action. This is just pure, raw, brute force. Imagine a huge wave slamming into a cliff. It forces water and air into every little crack. That air gets compressed with incredible force and acts like a tiny explosion, blasting the rock apart from the inside.
Next on the list is abrasion. This is when the waves start using tools. They pick up sand, pebbles, even small boulders, and just hurl them against the face of the cliff. It is literally like using sandpaper, just constantly grinding and scraping away at the rock surface, bit by bit.
Then we've got corrosion, and this one is a chemical attack. Just like acid rain, seawater itself is naturally a little bit acidic. Now, over thousands and thousands of years, this weak acid can slowly dissolve certain kinds of rock. Think of the famous White Cliffs of Dover, which are made of chalk. The sea just carries them away molecule by molecule.
And finally, there's attrition. Now, what's so interesting here is that attrition doesn't actually erode the cliff itself. Attrition is the process of all those rocks and pebbles the waves are carrying smashing into each other. As they collide, they break down, getting smaller, smoother, and rounder. This is the process that turns giant boulders into pebbles and pebbles into sand.
All right, so we've met all the individual players in this story, right? We have the silent breakdown from weathering, the sudden pull of gravity, and the nonstop power of the waves. So now, let's put it all together and see how this creates a coastline that is in constant, beautiful motion.
And you know what? The most important insight from this whole explainer can really be boiled down into one simple formula. It's not just one thing changing the coast, it's a powerful combination. Weathering weakens the cliff face, then mass movement brings all that weakened rock down to the shore. And finally, wave action either smashes away at the base of the cliff or carries all that material away. It is a continuous, connected cycle that just never, ever stops.
And that brings us to one last, really crucial thought. We've just gone through the natural mechanics of how a coastline changes over huge spans of time. But what happens when we throw a new variable into the mix? As our climate changes and sea levels begin to rise, all of these natural forces we talked about are going to accelerate. Higher seas mean waves can reach farther inland with more energy, attacking the base of cliffs more relentlessly. The entire cycle we've just broken down could speed up dramatically. It's a powerful reminder that while these forces are natural, their speed and their intensity are being influenced more and more by us. Definitely something to think about the next time you visit the coast.